this video, we're going to learn about wave properties of particles. We're going to start with the de Broglie wavelength, lambda. So the equation is lambda equals to h over p, where p is a momentum, p equals to mv, h is a Planck's constant, 6.63 times 10 to the power of negative 34 joule second, and lambda is a wave characteristics of any particle. The unit for lambda is meter. From momentum p equals to mv, lambda kita boleh expand equals to h over mv. It shows that the heavier the mass, the shorter the lambda, or the faster the mass, the shorter the lambda. And then we're going to do some rearrangement where we use mass as the subject, m equals to h over lambda v, and from energy of a photon, kita combine E equals to mc squared, combine dengan mass tadi, and kita dapat E equals to hc squared over lambda v. And disebabkan c ialah speed of light, 3 times 10 to the power of 8 meter per second, kita boleh cancelkan v tadi. And we got the energy of a single photon in terms of the Broglie wavelength is E equals to hc over lambda, where the E, the unit for E is joule. Let's go to the de Broglie wavelength in terms of voltage and kinetic energy. In an electron microscope, wave behaved by electron is the kinetic energy equals to electric potential energy. Bila kita kembangkan half mv squared equals to qv. Equation ini ada dekat dalam topik 1. Disebabkan Q boleh jadi positif ataupun negatif, we're going to take electron. So mv squared equals to 2ev. When we rearrange, kita akan dapat momentum sama dengan cert2 mev. Kita combine dengan de Broglie wavelength, and kita dapat in terms of voltage, lambda sama dengan h per cert2 mev, where E is 1.6 times 10 to the power of negative 19 coulomb, mass of the electron is 9.11 times 10 to the power of negative 31 kilograms, and if you are to change the unit for energy, you can use it 1 electron volt is equals to 1.6 times 10 to the power of negative 19 joule. Next, since energy can be electric potential energy or electron volt or kinetic energy, we substitute electron volt kepada kinetic energy, and we got lambda equals to h per cert2 mk, k as in kinetic energy. Let's try this tutorial question. In a transmission electron microscope, electrons are accelerated through a 200 kilovolt potential difference. Calculate the kinetic energy. And because we are provided with a voltage and we are looking for the kinetic energy, let's find the equation that relates voltage and also the kinetic energy. So I'm going to take this one. So K equals to EV, E as in 1.6 times 10 to the power of negative 19, and times the voltage given in the question. So the answer is 3.2 times 10 to the power of negative 14 joule. Question B, the momentum of the electron. Now that we have kinetic energy, let's find the momentum. Momentum is P. Since we know lambda equals to h over P, where P equals to cert2 mev, we can also use P equals to cert2 mk. So let's take this one. So we substitute everything. M is the mass of an electron, 9.11 times 10 to the power of negative 31, and the answer is 2.415 times 10 to the power of negative 22 kilogram meter per second. And lastly, they are asking for the de Broglie wavelength. And since we already have the momentum, let's just use this equation. We substitute the Planck's constant and also the momentum that we got from question B. So the answer is 2.75 times 10 to the power of negative 12 meters.